Alright, so quickly going over these. Here we would subtract 5. We get 4x equals 24. And when we divide by 4, you get x equals 6. Now, a new thing that we're going to start seeing this chapter is, remember, we did some set notation last chapter. So when you get an answer, when the x is by itself, you want to put it in those curly brackets. That's called set notation. That's a solution set. And you'll see that in your book when you look up the answer keys. You'll see the set notation. All right, for the second one, first thing we have to do here is distribute. So we would get 8x plus 4 equals 29 plus 6x, and then minus 15. We want to then combine our like terms. So 29 minus 15 is 14 plus 6x. And then when we go and we want to get all of our x's on one side and numbers on the other, just like we did the problem above now, we can subtract 6x, subtract 4, and we would get 2x is equal to 10. And when we divide by 2, we get x equals 5. Again, we'll put that in our curly braces, so the solution set is 5. What? That's just a mathematical solution set, and you're going to see that in the book, so just be used to that. All right, so that again, those first two problems are pretty straightforward. Another part of this section is talking about the difference between an algebraic expression and an algebraic equation. Okay, so you can underline here, algebraic expression versus algebraic equation. And then go ahead and actually write each of these, the first expression there, and then the equation on the right there. Okay. Makes sense. Yeah. So the first thing you might notice is when it is an expression, again, there's no equal sign. Because once you have an equal sign, then it's an equation. That's the definition of equation. Equation has to have an equal sign. You also kind of want to notice the difference in directions. When it's an expression, it says simplify, but when it's an equation, it's going to say solve. When you see that word simplify, simplify means to follow PEMDAS. And it just means get this expression into the most equivalent form by using PEMDAS. So P is for parentheses. There is nothing inside the parentheses that we can do there. There's no exponents, so we would multiply first. So I distribute the 3 to the x and get 3x. 3 to 7 is negative 21. And then remember, this is really like a negative 1 times, so I have to distribute a negative 1 into my second set. So minus 5x plus 11. Again, there is no equal sign. So the next thing we're going to do in PEMDAS, there's no division. We look for adding, subtracting from left to right. So I'm looking for like terms. 3x minus 5x is negative 2x. Negative 21 plus 11 is negative 10. Notice there is no equal sign at the end. It's just one expression. That's the simplifying. When we're solving, again, we have an equation now. So we are going to still, in the beginning, simplify it to make it a little easier. So my first couple steps are still to follow PEMDAS just to make it easier. So I would still distribute the 3, and I would still distribute the -1. So we get 3x minus 21 minus 5x plus 11 again. But now it's equal to 14. We're still going to combine our like terms. So when I still do that, I'm still going to get negative 2x minus 10. But again, now it's equal to 14. So these first, when we have an equation, those first couple steps are going to be the same. We're trying to make it as easy as possible. But now we have to get the x by itself. So once we get the x by itself, that's when we solve it. That's when we do PEMDAS backwards now. To get everything, undo everything now to get the x by itself. So now I would undo the addition subtraction, in this case add 10. And then divide by -2. Again, as I work backwards, undo addition subtraction, undo multiplication division. So we get x equals -12. So these steps here are the solving, which is the PEMDAS backwards. But again, in the end, notice I have x equals. Okay, if you have an equation, you need x by itself, x equals. If you have an expression, there's no equal sign. So that, again, that was part of this section. And then the last part of the section is rational equations. All right, so rational equations. What are they? Rational equations are equations that have fractions in them. So we did rational expressions last chapter. That's what those pink stations were, where they had the fractions and we multiplied and added them and divided them and just simplified them. But notice none of those pink stations that are still hanging up, none of those have equal signs in them, right? They were just expressions. So now how are we going to do it if we have an equation? So no one really likes fractions all that much. So our goal is to eliminate the fraction. That's what our ultimate goal is. And the way we're going to eliminate those fractions is to multiply the entire equation by the common denominator over 1. So that means you're going to multiply all the tops by the common denominator, and the bottoms of the denominators will stay the same. Let's go to the 800, so I think that should be open. That's what we're supposed to send you guys. Okay. All right, so looking at this problem, x minus 3 divided by 4 equals 5/14 minus x plus 5 divided by 7. So notice this is now an equation as opposed to an expression like we were doing on the pink stations. So we still are going to think about what is our common denominator, or what is a common multiple of 4, 14, and 7. 28 is our first common multiple of all 3. Okay, so I'm going to write just CD equals 28, meaning common denominator is 28. Based off what we just wrote up here, I have to take my entire equation and multiply it by 28 over 1. It's not going to. We're just trying to, our goal is to eliminate the fractions. Okay? So we'll see how that works in one moment. So one of the things I did notice on your test that sometimes, especially when you don't have a calculator, you have to really use the simplifying strategies before you can actually like multiply things out. Some of you aren't doing that, and then you got really big numbers, and then you couldn't go any further because you were stuck. here is where you really want to pay close attention to what you are doing. So what we are doing here is we're multiplying all the tops by 28. So I'm going to write this as 28 times the quantity of x minus 3, and that would be over 4, equals, I'm going to just write this as 28 times 5 divided by 14 minus, I'm going to write this as 28 times the quantity of x plus 5 divided by 7. Because now what I should be able to do is I should be able to reduce. Notice all this is factored. There's multiplication here, there's multiplication here, there's multiplication here. So I can reduce those factors. I can take this 28 divided by 4. What's 28 divided by 4? 7. So I get 7 times the quantity of x minus 3. Notice that fraction's gone, right? That's what we wanted. Go over here. 28's a factor. What's 28 divided by 14? 2. 2 times 5 is what I'm left with there, minus, and then I can do 28 divided by 7, which is 4, and I'm left with x plus 5. So again, using this order makes the numbers stay small so that we don't need a calculator. Okay, now it's just, our goal was eliminating the fractions, right? We just eliminated our fractions. That's what we wanted. This is now pretty much going to be like a regular problem you just did as the bell ringer. So we want to simplify first, so we can distribute that 7. I want to multiply the 2 and the 5 together to get 10. And then I will distribute the negative 4 and get negative 4x minus 20. We can combine our like terms on the right side. And 10 minus 20 is negative 10. We will get our x's on the left and constants on the right. 7x plus 4x is 11x. Yeah. Yep. Give me 1 second. 11x equals 11. We divide by 11, so x would equal 1. And we do our curly brackets with a 1 there. All right, I'm going to put a problem up for you to try. Once you have that answer, then you can work on your homework, which is page 120, 7 to 19 odd. You all got this? All right, so go ahead and try that one.